We want to know where this function is concave up and where it's concave down. Concavity is related to the second derivative, so we need to start by taking two derivatives of this function. It's just the power rule, fortunately. That's nice. And the second derivative, we've got 12x squared minus 12, which factors to 12 times x squared minus 1. The function will be concave up if the second derivative is positive. It will be concave down if the second derivative is negative. So basically the question is, where is this positive and where is this negative? So that looks like 12x minus 1 times x plus 1. We can make another sign chart, -1, 1, coincidentally, same points. These are not critical points, but they're potentially inflection points. Critical points would be where the first derivative is equal to 0. We are looking at the second derivative and where that is 0. So we're going to label it to make sure we keep track of what we're doing. We're going to pick points to evaluate the second derivative, and let's pick -2 and plug it in here to the second derivative. If we do that, we get something positive. If we plug a 0 in there, we get 12 times -1 times +1, which is negative. If we plug in a 2, we get something positive. So this is concave up like a cup, concave down like a frown, concave up like a cup. This changes concavity at -1 and at +1. Those are inflection points, and we can say now that F is concave up on -infinity to -1 and 1 to infinity, and it's concave down on -1 to 1. And that is the answer to this question. Where is it concave up? Where is it concave down? That's it. We map it out. Take the second derivative, set it equal to 0, make one of these little sign charts, and we can tell everything about where the function is concave up or down.